Kirchhoff's rules. So, when we have a complex circuit, we have some resistors in series and some resistors in parallel. It might look like this. So I have 2 in parallel with 1 in series. Ohm's law still applies to each individual element, the battery, an individual resistor, okay? Or I could say each branch. So I could take just the 2 in parallel, and Ohm's law would still apply. Or I can look at the whole circuit. All right, so what are these rules? So there's 2. The first is the junction rule. All right, also known as conservation of charge. Okay? When the path of a circuit splits, it's called a junction, but the total current has to be conserved. We talked about this a little bit with the parallel circuits. The loop rule is the second rule. It's better known as conductors want to be equipotential. So if I have a wire that's connected to the positive terminal of the battery, I have to assume that it's at the same potential as that terminal of the battery until I hit some resistance and I get a voltage drop. All right, because I then dissipate some power, I use some of my energy. So around any given loop in a circuit, the potential difference must be 0. All right, what does that mean? Let's look at it in action. So here's a circuit, all right, and the resistors 1, 2, and 3. Sorry, 2 is a little bit hidden there. So let's look at the junction rule. Okay, so the current going through resistor 1 has to be the same as the current through 2 plus the current through 3. All right, I didn't create any new charges or get rid of any, so the ones that go through 1, they have a choice of which way to go, all right, and they'll do that according to Ohm's law, but there's still the same number of charge carriers moving through the circuit. All right, and then the loop rule means that the potential drop over 2 has to be the same as the negative potential drop over 3. But in that case, it's going the other direction, so that's why you get a weird negative there. Basically, what this tells you, right, is the wire that's vertical between resistor 1 and resistors 2 and 3, that's at some potential, all right? An electron moving through there, okay, or really, it's the positive charge carrier. Let's think about it that way. The positive charge carrier has that some potential leaving the positive terminal of the battery. It loses some of that energy through resistance in resistor 1, all right? And then it shouldn't matter whether it goes through resistor 2 or resistor 3. By the time it gets back to the negative terminal, it has to be back at 0 potential. So the voltage drop across 2 has to be the voltage drop across 3. So a way to remember this is a series circuit, or a part of a circuit that is in series, splits voltage. Okay? You're going to lose energy one chunk at a time. But the current has to stay the same. A parallel circuit, or a part of a circuit that is parallel, splits current. All right? The voltage drop will be the same, but the current you had coming in has to split, and then when it gets to the end, it has to come back together. I know this is complicated, but keep it simple. So if you use Ohm's law, start with a simple portion of the circuit and work your way out to the whole circuit. This is a more complicated circuit than we are going to see in AP Physics 1, but I want to show you that if you look at this, there are 2 places where you could start with a very simple portion. Okay, this bit here, I just have 2 resistors in series, so I can start calculating things because I can add up an equivalent resistance if I know the resistors there. Or I have 2 in parallel, okay, over here. So if I was solving this circuit, I would probably start with the series because I don't have to do anything with fractions, and then I go to the parallel one. Once I have those 2, my next step is this middle branch of the circuit, okay? So once I have taken that bottom middle set that's in parallel, and I've solved for an equivalent resistance, I can now treat it as just a single resistor with that equivalent resistance. That's the beauty of Ohm's law. All right, so then now I have 2 in series along that middle branch. Hey, I just add up those resistances. Cool. Then the final step is the whole circuit. I have 2 parallel branches, each with some resistance, all right, that is equivalent to all the resistors in that branch. And then I just use my resistance of some resistors in parallel to solve the overall equivalent resistance of the whole circuit. Okay, I know that sounded complicated, and bottom line, here's some problem-solving tips for circuits. And this is going to be the end of the unit. If you are asked to maximize resistance, put your resistors in series. And vice versa, to minimize resistance, put your resistors in parallel. If you are asked to rank bulbs in terms of brightness, you're actually solving for the power of each, okay? If they're all the same resistance, you can use the current. But if you have different resistances, you must solve for the power. And for even slightly complex circuits, take them one step at a time, and you'll be okay.